Okay, so we're going to look at percentage composition, and here's my favorite thing. I love teaching percentage stuff because you all know how to do percentages. Because if I, and this, you guys all have pretty strong math skills, but when I teach stuff to people who have, what I'll call weaker math skills, and they say, I get confused by percentages. Any percentage is the part divided by the whole times 100. And that gives you a percentage of whatever. If I hand you back a test that had, 42 questions on it, and you got 37 of them right, you immediately grab a calculator and figure out your percentage by dividing the part that you got right by the whole number of questions. That's all percentages boil down to, is part divided by whole. And just a little bit of etymology here. Cent, do you recognize that? Refers to how many? Hundreds. Centuries, and cents are 1/100th of a penny. Got that? So a per cent is per 100. This is why we do the multiplication by 100 thing. Okay. So with percentage comp, the part that we're looking at is the mass of a particular element in 1 mole of the substance. And we're dividing that by the molar mass of the whole compound. Multiplying it by 100, and you get the percent comp of that element. So if we do the percentage comp of sodium in sodium chloride, we're going to take the mass of sodium in 1 mole of sodium chloride, divide it by the formula mass of sodium chloride, and multiply by 100. Okay, so we've got the formula mass of sodium chloride, 58.44 grams of NaCl. Notice that I labeled these things. I'm writing here that there are 22.99 grams of sodium in every 58.44 grams of sodium chloride. And again, it's a good habit to get into labeling your chemicals. And when you're writing a fraction like that, not just putting the numbers, because the labels and the chemicals tell you something. Okay, what do you get? So we got a raw answer of 39.339495. We can have 4 sig figs, the way I calculated this, because everything that went into this calculation had 4 numbers, had 4 sig figs. So we would get 39.34% sodium. Sodium chloride is 39.34% sodium. Okay, let's do another one. Okay, so we want the percent composition of carbon in C6H12O6. And to do that, we're going to need the mass of carbon in 1 mole of C6H12O6 divided by the mass of 1 mole of C6H12O6 times 100. So in every mole of sucrose, how much carbon do we have? Well, C 12.01 times 6, what do we get? Okay, so I sort of did a little cheater shortcut, and I'm showing that the mass of the whole thing is 180.18 grams per mole. So I'm going to shrink all of this. Okay, so we come up with sucrose being 39.99% carbon. Seem pretty easy? The most common permutations here are find the percentage comp of each element in a given compound. I'll tell you something that would be a fantastic question. Let's do it as a practice. What the heck? I'll give away what would be an excellent test question. Compare the percent composition of iron in iron 2 oxide and iron 3 oxide. Ooh, what does this require? All your skills. All your mad skills. You got to do 2% comps. But first, you got to write formulas. What's interesting to me, anyway, is that these 2 oxides of iron actually have different colors. One is what we think of as rust-colored, and one is a black iron oxide. So, same thing for copper oxides. Copper 1 and copper 2 oxide have different colors, and you'll see evidence of that when we go to the Carnegie, because there are some minerals that are formed with copper oxides, and they have different colors based on which ions of copper predominate. Okay, so now, with that part out of the way, we can do our percent comp. When we compare them, so do you have the same numbers I do? We've got 77.73% iron and iron 2 oxide. We've got 69.94% iron and iron 3 oxide. If you were really going to compare them, you would say something like, let's see, we could do, we could say iron 2 oxide has 1.1 times the percentage of iron that iron 3 oxide does. You know, we could make some sort of numerical comparison. Obviously, you can say there's a higher percentage of iron in iron 2 oxide than iron 3 oxide. Fairly simple, fairly straightforward. Okay.